Imagine opening your door one day and finding trash piled up to your knees. Aluminum cans, plastic wrappers, and scraps of paper scattered everywhere. Sounds far-fetched? The truth is, we generate over 2 billion tons of waste every year, and aluminum cans, the ones you hold every day, make up a significant part of that. Did you know that just last year, the world produced 180 billion aluminum cans? That's enough to build a tower 10 times taller than Everest. This creates an enormous demand for the recycling industry. So how do we save millions of cans from a tragic fate? The answer lies in massive recycling plants, where millions of cans get a second life every day. Today, I'll take you through that journey, from chaotic piles of waste to shiny aluminum ingots, and show you why this is one of the ways we're fighting the ever-growing mountain of trash. Sounds exciting? Let's dive in. The journey starts with you. Yes, from the very moment you toss that can into the recycling bin. But have you ever really noticed the recycling bin near your house? Next time, try dropping a can in. It's the start of an incredible adventure. Globally, around 75 to 80% of aluminum cans are collected, far more than plastic or glass. In Germany, they even pay a few cents for every can you bring in. Small but mighty. Once collected, the cans are sent to a pre-processing facility where they pour out like a silver flood. But it's not just aluminum in the mix. Sometimes there are steel cans, plastic, or even banana peels. This is where smart machines take the stage. Optical sorters work like superhuman eyes, firing light at each can and identifying aluminum based on how it reflects. Since aluminum shines brighter than steel or plastic, the machine detects it instantly. In just a few seconds, hundreds of cans are sorted with 99% accuracy. At a major facility like this, up to 50,000 cans can be processed per hour. That's 1.2 million cans a day. Now here comes the thrilling part. The scattered cans are fed into a massive compactor, so powerful it could crush a car. With a thunderous boom, thousands of cans are flattened in an instant, compressed into dense cubes weighing hundreds of kilograms. Why do this? Because loose cans take up a massive amount of space. A truck filled with uncompressed cans can only carry a few thousand. But once compacted into blocks, it can hold hundreds of thousands, saving up to 70% in space and transportation costs. These aluminum blocks look like rough, metallic bricks waiting to be melted down. At the factory, automated conveyor belts replace trucks to reduce emissions and dust. Watching them in motion, you can see an entire story unfold, a testament to human ingenuity and efficiency. This is the climax of the story, and it begins with a thunderous spectacle. Before entering the furnace, those gleaming aluminum blocks aren't just tossed straight into the fire. First, they must pass through a giant shredder. With a roaring clatter, thousands of cans are torn into tiny fragments, like a silver snowstorm cascading down. After shredding, the aluminum fragments are tossed into a blazing furnace heated to 800 degrees Celsius, hotter than volcanic lava. Can you guess how long it takes for the aluminum to melt? Just 5 minutes, faster than brewing a cup of tea. At this temperature, the aluminum softens and then liquefies into a shimmering silver stream, glowing like a river of falling stars in the dimly lit factory. But why is there slag? When aluminum melts, anything that isn't pure metal, like leftover paint, plastic coatings, or natural aluminum oxides, doesn't dissolve. Instead, these impurities rise to the surface, forming a layer of slag. Workers or machines skim it off, leaving behind pure molten aluminum. A large factory can melt 100 tons of aluminum a day, enough to make millions of new cans. The molten aluminum is poured into large molds, gradually cooling over several hours to form solid ingots or sheets. These uniform aluminum billets, each weighing tens of tons, are made from millions of recycled cans. Recycling just 1 ton of aluminum saves enough electricity to power a home for 3 years and reduces 9 tons of CO2 emissions. The same impact as planting 150 trees. From aluminum ingots, the production line transforms them into brand new cans in just a few hours. The Coca-Cola can you're drinking today could contain up to 70% recycled aluminum from this very plant. A recycled can makes its way back to supermarket shelves in just 60 days, faster than growing a head of lettuce. And just like that, we've completed a remarkable journey from discarded aluminum cans buried in heaps of trash, through colossal machines, shimmering molten metal, and finally back into brand new cans ready to return to life. But this story isn't just about machines or technology. It's about a perfect cycle, a way to transform something seemingly worthless into something valuable, not just once, but forever. Every day, millions of cans are reborn in factories like this. But the real magic? It all starts with one simple action. It takes just 1 second to drop it in the recycling bin. And with that, you help save energy, reduce pollution, and keep the air a little cleaner. When you look at these recycling plants, you'll see more than just factories. They are symbols of hope, proof that we can correct our mistakes and build a more sustainable planet. The roar of the shredders, the flow of molten aluminum, the birth of gleaming ingots, it all plays like a symphony of renewal. And the best part? You are part of this symphony. Every time you choose to recycle, you're adding a note to a greater melody, one that echoes across the world. Thank you for joining me on this journey. If you found this story worth sharing, don't forget to like, share, and subscribe. And next time you hold a can in your hand, remember, it's not just trash, but a chance to make a difference. See you in the next adventure. Hello, everyone. Imagine you are holding a shiny, flexible, and strong copper wire in your hand. But do you know where the journey to create this wire begins? It could have been part of an old air conditioner, a broken motor, or even the electrical cables in your home. Copper is not only a precious metal, it is also an indispensable part of our modern life. And the most special thing, copper can be recycled infinitely without losing quality. In today's video, we will explore the magical journey from lifeless scrap copper to brand new copper wire, ready to serve modern constructions and equipment. Scrap collection is the first step in a seemingly simple process that serves as the foundation for the entire production chain. Did you know that millions of tons of electronic equipment and machinery are discarded globally every year, and a significant portion of that waste contains valuable copper treasures? Uneven electrical cables and electrical equipment are a rich source of copper. According to statistics, global e-waste is expected to reach 74 million tons by 2030, of which cables and wires account for a significant portion. These figures not only show the potential amount of copper that can be recycled, but also highlight the importance of properly disposing of these materials. Scrap copper collection occurs at many levels, from households and small businesses to large-scale e-waste processing centers. Collection centers not only collect materials but also conduct preliminary sorting to ensure the highest efficiency when entering the recycling process. Bundles of old cables, Heavy motors or even small pieces of debris have the opportunity to become part of a new life. Once collected, scrap copper is brought to the plant to begin the sorting process. This is an extremely important step because it determines the quality of the copper after recycling. Copper can exist in many different forms and needs to be carefully classified. Pure copper, also known as red copper. This is the purest type of copper, the best conductor of electricity, and is often found in electrical cables and electronic equipment. Copper alloys, including brass-zinc alloy, bronze, and copper-nickel. These alloys are often used in the production of household and industrial equipment. Copper scrap, small, scrap pieces of copper from the manufacturing process or dismantling of equipment. Once sorted, scrap copper is cleaned to remove any remaining impurities. This is an important step to ensure the best quality of recycled copper. For electrical wires, modern wire stripping machines such as SuperStrip will remove the plastic insulation without reducing the weight or quality of the copper. Compared to the traditional burning method, this method is not only safer, but also more environmentally friendly. For electric motors contain copper coils wrapped in iron cores. The cleaning process begins with the disassembly of mechanical parts using a specialized cutting machine. The copper coils are then separated using a core separator or manually, which completely removes the surrounding iron without damaging the copper wire. For air conditioner radiators often have copper tubes nested in aluminum. A specialized metal separator presses and separates these metal layers. This process ensures that the maximum copper is recovered without any impurities from the aluminum. Modern recycling plants also use dry separators such as dry separators to separate copper and aluminum from PVC or rubber. The wire is fed into the shredder and the mixture of plastic and copper is passed through a pneumatic separator. A strong air stream blows the lighter plastic or rubber coating off the copper, while the heavier copper wire falls to the bottom. Once the copper has been thoroughly cleaned, it is fed into a furnace that heats up to around 1085 degrees Celsius, the melting point of pure copper. But don't think it's just a simple process of heating up the metal. There's an art and science behind these furnaces to ensure the recycled copper is of the highest quality. The smelting process begins with furnace preparation. Factories use modern induction furnaces or electric arc furnaces to precisely control the temperature. Induction furnaces are preferred because they heat up quickly and evenly, saving energy and minimizing heat loss. Copper ingots and scrap are fed into the furnace via an automated conveyor system, ensuring safety and efficiency. As the furnace reaches the required temperature, the copper begins to change from a solid to a liquid state. At this stage, the difference in density between the copper and other impurities becomes apparent. Light impurities such as oxides and dirt rise to the surface, forming a thin layer of slag. This slag is carefully removed with specialized tools to ensure that it does not mix with the pure copper below. Heavier metals such as lead or iron sink to the bottom of the furnace and are then separated. An important factor in this process is controlling the atmosphere in the furnace. If the air contains too much oxygen, the copper can oxidize, forming a layer of copper oxide that reduces the quality of the final product. Therefore, many factories use inert gases such as argon to create the perfect smelting environment, keeping the copper in its purest state. Once the copper is completely melted and impurities have been removed, the molten metal is poured into molds. The pouring of the molten copper must be done with extreme care to avoid creating air bubbles or impurities. Molds are usually made of cast iron or heat-resistant steel, which can withstand high temperatures and help the copper cool evenly without cracking or deforming. Advanced factories also apply heat recovery and energy reuse technology. Metal dust and exhaust gas recovery systems not only reduce waste but also protect the environment. Once cooled and solidified, the copper is removed from the mold and moved to the next step in the recycling process: refining. These copper ingots, although highly pure, still need to undergo electrolysis to completely remove any remaining impurities and reach near absolute purity. To achieve maximum purity, copper undergoes an electrolytic refining process. In this process, raw copper is used as the anode, while pure copper is used as the cathode. When an electric current is passed through, copper ions move from the anode to the cathode, leaving behind impurities such as iron, nickel, and lead. After refining, the copper reaches a purity of up to 99.99%, ready for the process of creating new copper wire. The copper is reheated to make it more pliable and easier to shape. To increase the ductility and reduce brittleness of copper wires, they are annealed by heating them in a furnace at a moderate temperature and then cooling them slowly. This process helps the copper wire achieve the perfect balance between hardness and ductility. After the copper wire has reached the desired size and mechanical properties, it will be coated with an insulating resin to protect it from oxidation and ensure safety when transmitting electricity. The finished copper wires are rolled into large coils or cut into lengths as required. They are then packaged and shipped to factories or manufacturing facilities for use in electronic products, cables, or other industrial applications. The copper recycling process not only saves natural resources, but also reduces environmental pollution and energy consumption compared to mining virgin copper. Recycled copper still retains the physical and chemical properties of pure copper, ensuring optimal performance in technical applications. Thank you for watching the video. If you find it useful, please like, share, and subscribe to the channel. Press the notification bell so you don't miss the next videos. Now goodbye and see you again. Hello everyone, welcome to the IronHand Tech channel. Today let's embark on a fascinating journey with plastic bottles, starting as waste and ending up as useful items in our daily lives. Let's dive in. Here, millions of plastic bottles are collected from various places, ready for the recycling process. First, these bottles are sorted by material. The most common and recyclable type is PET, polyethylene terephthalate, bottles. This is a type of polyester widely used in producing drinking water bottles, detergent bottles, bottle caps, and many other consumer products. PET is known for its durability, non-toxicity, and water resistance, making it one of the most popular materials in the packaging and storage industry. After sorting, the bottles are stripped of labels and caps. Now they're ready for shredding, a critical step in the recycling process. The plastic bottles are transported on a conveyor belt to the shredder. The blades inside the shredder crush the bottles into small, transparent flakes. The shredded plastic flakes are often mixed with impurities, such as bits of labels, bottle caps, or other impurities. So the next step is to clean these plastic flakes using a flotation method. The flakes are placed in a large water tank, where they are stirred. Lighter impurities like PVC bits and label fragments float to the surface, while heavier PET flakes sink to the bottom. Since the clean flakes are wet, they need to be dried. A dryer handles this perfectly using high-speed airflow to evaporate all the moisture. After drying, the PET flakes are packed and sent to another facility for further recycling. The PET flakes are melted and extruded into long strands of PET plastic. These strands are immediately cooled with water and then fed into a cutting machine, where they are chopped into small pellets. These pellets are mixed with virgin polymer to ensure the desired plastic properties. They are also colored as required and prepared for new products. The insulating layer of electrical wires is crucial. It prevents electrical leakage, protects the wire core, and enhances the wire's appearance. The plastic pellets are fed into an extrusion machine. High temperatures melt the plastic, which is then pushed through a mold shaped like a tube. As the plastic emerges, a wire core is threaded through it. The melted plastic immediately coats and adheres uniformly to the wire core and is cooled instantly. A pulling machine stretches the wire and rolls it into coils. This process creates colorful electrical wire coils. And just like that, colorful electrical wire coils are formed. From discarded plastic bottles, now transformed into a new beginning. Plastic waste decomposes very slowly in the natural environment. Each type of plastic has a different decomposition time, which is often extremely long. For example, plastic bottles take 450 to 1,000 years to decompose. According to a 2022 report by the Organization for Economic Cooperation and Development, OECD, globally, most plastic waste ends up in landfills, incinerated, or leaks into the environment, with only 9% successfully recycled. Recycling plastic bottles saves a significant amount of energy. While it doesn't necessarily address end-of-life issues when bottles are thrown away, it reduces resource consumption during production. Recycling consumes 75% less energy per bottle, with some estimates suggesting the energy savings could equal removing 360,000 cars from the road. Thank you for joining me on this journey. If you found this video helpful, don't forget to like, share, and subscribe to the channel so you won't miss exciting videos. See you in the next one. Sugarcane, often referred to as green gold, is not only a source of sweets but also an important raw material in the renewable energy sector. According to the World Bank, global sugarcane production in 2021 was about 1.85 billion tons, which means we have about 185 million tons of bagasse produced each year. With this extremely huge amount, bagasse has become a raw material for bioenergy production, food packaging, paper. So how does this recycling process work? In today's video, we will take a comprehensive and detailed look at the process of recycling bagasse, a typical example of the circular economy. The journey begins in the vast sugarcane fields of Brazil. After 14 months of planting and tending, farmers harvest the sugarcane using advanced machinery that minimizes waste. The harvested stalks are transported to nearby factories, where the extraction process begins. The cane stalks, up to 6 meters tall, are chopped after harvesting. Large crushers crush the stalks, extracting the juice. This juice is processed into sugar or ethanol, leaving behind the bagasse. Conveyors carry the bagasse to storage areas where it is prepared for further processing. Since there is still water inside, the bagasse must be dried to reduce the moisture content. This step is important to increase the calorific value and make recycling easier. Bagasse can be spread out in the open to dry in the sun or in modern factories. Large rotary mechanical dryers or fluidized bed dryers are used for faster and more uniform drying. After drying, the moisture content of the bagasse is reduced from about 50% to less than 10%, making it ideal for use as a raw material. After processing, bagasse is ready for recycling processes. Bagasse is mainly used as a biofuel to generate energy, powering sugar mills and feeding into the national grid. First, bagasse is fed into a high-efficiency boiler to burn to generate heat. The heat creates steam, which rotates a turbine to generate electricity. This electricity is reused for the recycling plant itself, and the excess electricity generated is fed into the national grid. Brazil, the world's largest sugar producer, uses bagasse to generate 9% of the country's electricity. More than 400 sugar mills in Brazil have installed biomass boiler systems, providing about 20 terawatt-hours of energy per year, enough to power about 10 million homes. In addition to energy, bagasse is also a versatile raw material for the production of bioproducts, most commonly paper and cardboard. About 25% of bagasse is recycled into paper and cardboard. Bagasse fibers are cleaned and ground into pulp. The pulp is then pressed and dried to form environmentally friendly paper and cardboard products, serving as a sustainable alternative to wood-based materials. 1 ton of bagasse can produce about 150 to 200 kilograms of paper. Using bagasse to make paper helps reduce the felling of 20 million trees each year and reduce water consumption by about 30 to 40% compared to producing paper from wood. In addition, bagasse is also processed into pellets or mixed with other feed ingredients, providing a sustainable and cost-effective source of nutrition for livestock. First, bagasse is chopped and fermented to make it easier to digest. Then nutrients such as protein or trace minerals are added. Finally, the mixture is packaged and preserved for livestock feed. Fermented bagasse contains about 30 to 40% fiber, which helps improve livestock digestion and reduce livestock costs by 20 to 30% compared to traditional feed. Bagasse is also used to make eco-friendly biobricks or cement. First, the bagasse is crushed, then dried to reduce moisture. Then the bagasse fiber is mixed with cement or other bioadhesives to create a mixture. The mixture is poured into molds, compacted to shape and increase durability. The product is dried or fired to achieve the required hardness before use. As a result, panels or bricks made from bagasse are lightweight, well-insulated, and suitable for sustainable construction projects. In Thailand, a factory produces 5 million bagasse panels per year, reducing the consumption of 200,000 cubic meters of wood and saving about 15,000 tons of CO2 emissions. Bagasse recycling exemplifies the combination of innovation and sustainability. By converting agricultural waste into energy, valuable bioproducts, and chemicals, the process not only meets energy needs, but also sets the standard for environmentally friendly practices. This comprehensive process ensures that every ounce of sugarcane is used, leaving no waste behind. As we continue to seek sustainable solutions for the planet, bagasse inspires us to tap into the full potential of renewable resources. Thank you for watching the video. Please leave your thoughts in the comments below. If you find it interesting and useful, please like and share the video so that it can reach more people. Now goodbye and see you in the next videos. What would you do with an old torn PP woven bag? Would you toss it into the trash and let it end up in a massive landfill, where it might take 200 years, or even longer, to decompose? Or worse, never decompose at all, while slowly releasing microplastics into the environment day by day, bit by bit, endlessly? But what if I told you there's a better destination for those bags, a PP woven bag recycling plant? It's the beginning of a rebirth journey, a magical transformation from plastic waste into a new product. From a worn-out bag, it becomes a brand new one, ready to serve again. This is the incredible journey of recycled polypropylene plastic. The story begins with collectors, scrap buyers and small traders, roaming through farm markets, fields, and construction sites in search of used woven bags. Some bags remain intact, others are worn and broken, but all are made from polypropylene plastic, or PP, one of the world's most durable, recyclable, and valuable plastics. All the bags are loaded onto trucks and transported to the recycling plant, where the real journey begins. Old woven bags are placed on a conveyor belt by workers and sent directly into a giant twin-shaft shredder, a roaring steel beast at the heart of the factory. Two rotating shafts spin in opposite directions, tearing through thick fabric layers, shredding the bags into thin plastic strips just a few centimeters wide. Nothing escapes its crushing force. Below, another conveyor belt waits, ready to carry the shredded pieces straight to the next destination, the washing tank, where the old fabric fragments will get a thorough cleaning. The shredded bag pieces enter an automated washing system, a kind of industrial spa for plastic fragments. They pass through large water tanks, rotating blades, and high-pressure water jets that scrub every single piece. Sometimes hot water is used to remove grease and stubborn ink. This wash water can and should be reused. Professional plants often invest in closed-loop treatment systems to save resources and protect the environment. After cleaning, the plastic fragments are spun dry in centrifugal dryers, then heated with hot air to ensure they're completely dry. Now each piece is clean, dry, and ready for the fire. High-temperature extruders are ready, reaching 230 degrees Celsius. The plastic fragments are fed into the machine. Inside, a screw shaft compresses the molten PP plastic, pushing it through a mold. The plastic is extruded into long strands, like spaghetti noodles. These are quickly cooled in water and sent to a cutting machine, creating recycled PP pellets, tiny but infinitely reusable. From lifeless scraps, they've now become a new raw material, ready to be reborn into something useful. The small, powerful recycled PP pellets are delivered to a woven bag manufacturing plant. They're blended with a small amount of virgin plastic pellets to improve durability, shine, and product lifespan. Depending on the application, the operator may also add colorants, UV stabilizers, or special additives. All ingredients are measured precisely and blended before entering the extruder. Inside, the plastic is heated and pushed through microscopic nozzles, forming fine plastic threads. But it doesn't stop there. These threads are stretched by heated rollers to rearrange the molecular structure, increasing flexibility and strength. Cold air instantly cools the threads, which are then wound into large rolls resembling giant textile spools. This is the raw material for the next step, weaving the shape. Now comes the artistry. The thread spools are fed into circular weaving machines, industrial looms performing a mechanical ballet. Hundreds of shuttles spin and cross each other, interlacing the plastic threads into endless, tubular, woven PP fabric. And just like that, the bag's body begins to form. Each turn of the machine brings it closer to its final shape. If waterproofing is needed, the fabric passes through a laminating machine where a thin layer of PE film is pressed onto the surface under high pressure and heat, like adding a raincoat to the bag. Finally, if printing is required, rotogravure printers add product information, logos, and warning labels. Sharp, fast-drying, and long-lasting. At this stage, the woven fabric now bears shape, color, coating, and info, ready for the final stage: cutting, sewing, and finishing. The fabric is cut into pieces of the desired size, from 25-kilogram bags to jumbo sacks. Workers sew the bottoms, stitch the openings, and attach handles if needed. Each bag is carefully inspected, folded, and packed. They are shipped far and wide, to farms, cement plants, and warehouses, ready for new journeys, durable, strong, and looking like they've never aged a day. PP plastic doesn't degrade quickly, it doesn't vanish in a short time, but it can be reborn again and again, as long as we give it the chance. Every torn woven bag is not trash. It's a raw material waiting to be revived. It also provides jobs and income to many people working in the recycling industry. And maybe, next time you see a humble woven bag out there, remember that inside it lies an incredible journey of recycling, of hope, and of a second or even third life, shaped by the hands and minds of a modern, conscious society. Thank you for watching the video, and see you next time. Hello everyone. Nowadays, you can easily see ships with a tonnage of hundreds of thousands of tons moving at sea, waiting for goods or oil to reach all over the world. But the thing that helps them stop is the main character in today's video. To stop these giant ships, people have to use ship anchors, which consist of two main parts, the anchor and the chain. Made of alloy steel with the main components of iron, carbon, silicon, manganese, they are added with molybdenum or chromium for durability and superior corrosion resistance. They can operate for 20 to 50 years if properly maintained. However, nothing lasts forever. After a period of tireless operation, these chains will be retired. So what will people do with them? Considering the composition and technical properties of these chains, they can be an invaluable resource for other uses. So they will be recycled to continue a new life cycle. In today's video, let's learn about the process of recycling these anchor chains. First, after being removed from old ships, these anchor chains are transported to a recycling plant. Because of their large volume, removing anchor chains is a complex process that requires a high level of skill and close coordination to ensure safety. At the ship breaking yard, the process begins with securing the ship, collecting the chains, and lifting the anchors out of the water using a winch system. Workers then use chain cutters or link breakers to break up the chains, remove the connecting pins, and lower them to the ground using a crane. This is a local recycling plant where workers with rudimentary equipment use their skills to give them a new life. First, workers use oxyacetylene cutting machines to cut these links. The temperature generated by this cutting machine reaches 3,200 degrees Celsius, melting the steel, and the oxygen gas will blow strongly into the cutting area, helping to create a clean cut, making the steel material cut through without being deformed. However, the cutting process creates a large amount of smoke and sparks and requires high skills to operate safely. The links continue to be cut smaller until they are about 10 centimeters long. In countries such as Bangladesh, Pakistan, India, the ship recycling industry creates many jobs for people, but also brings many consequences due to unsafe working environments and rudimentary tools. Now our links are ready to start a new life. They are put into the furnace to heat up. The temperature of the furnace will reach about 800 to 1000 degrees Celsius. When the steel is red hot, its crystal structure changes, making the iron more flexible and easy to deform under the influence of external forces. Therefore, it is more convenient for the recycling process. After the steel is red hot, it will be shaped. This is the step that combines strength and skill, ingenuity. The automatic hammer provides strong impact force to shape, while the worker skillfully changes the position of the steel bar to shape. Under the great impact force of the hammer, the steel bar flattens. The worker skillfully places a small steel bar to create an eyelet. The steel is continuously heated to ensure the temperature is suitable for the shaping process. Each time it is heated red hot, the steel bar is given a new shape. The wings of the pickaxe are created by beating two parts of the chain to the sides. One wing is made with a pointed tip, the other wing is made with a flat tip. The pickaxe is shaped many times to achieve the desired shape and size. Finally, after cooling, the pickaxe is painted with a protective paint and is ready for a new life. The ship's anchor chain is made of hard steel, which has good resistance to force and abrasion. This steel is highly durable, so the pickaxe is not only durable over time, but also resistant to environmental impacts. Anchor chains, after long journeys at sea, after completing their mission, are recycled. This is the beginning of a new, more sustainable life cycle, a typical example of the circular economy. What do you think after watching this video? Let us know in the comments section below. Thank you for watching this video. If you find it interesting and useful, please like and subscribe to the channel so you don't miss the next interesting videos. Now goodbye and see you again. Welcome to the IronHand Tech channel. Today we embark on a special journey to discover how the mattress you sleep on, made from coconut coir, is produced. Coconuts are widely used in various industries. Its flesh is processed in the food, cosmetics, and pharmaceutical industries, while the husk is often discarded or burned. However, thanks to human ingenuity, coconut husks have been repurposed into an unexpected health product, the mattress you sleep on every day. It is completely natural and typically lasts over 10 years. So how is discarded coconut coir transformed into such an incredible mattress? What makes this process so fascinating? And what kinds of machinery contribute to this amazing transformation? Let's find out. Depending on the scale of production, coconut husks are typically collected from large factories that process coconut meat-based products or from smaller coconut processing facilities. Once gathered, the husks are transported to local factories, where they are transformed into coconut fiber rolls before being sent to mattress manufacturing plants. First, the coconut husks are placed onto a conveyor belt, which carries them to a grinding machine. Inside, the husks are separated into two components: fiber and coconut pith. The pith is repurposed for agricultural applications, while the fiber still contains impurities such as husk fragments, dust, and coconut dust. To ensure cleanliness, the extracted fiber is thoroughly cleaned using a large screening machine. This process improves the fiber quality by retaining only long fibers while discarding shorter ones, which fall below the screen. At this stage, we obtain clean coconut fiber. However, fresh coconut fiber contains high levels of lignin and tannin. When still moist, it tends to clump together, making it prone to mold and bacterial growth, which can reduce its quality and durability. This poses challenges for further processing, so the fiber must be properly dried. Transporting loose coconut fiber to mattress factories is inefficient and cumbersome. To address this, local factories compress the fiber into large, compact blocks, making transportation easier. In many local facilities, the fibers are also spun and rolled into large coils for more convenient handling and transport. After arriving at the factory, the coconut fiber is unpacked and loosened into soft, fluffy strands using specialized machines. The fibers are then transported on a conveyor belt, preparing them to be transformed into beautiful mattresses. The mattress manufacturing process varies depending on the final product. In some factories that use pure coconut fiber, the fibers are loosened, evenly spread on a conveyor belt, and then coated with a natural latex spray to create adhesion. After this, the fibers undergo a hot pressing process to shape them into mattress layers, which are then cut into the required sizes. A thin layer of adhesive is applied to the surface before the mattress is covered with fabric, making it ready for use. However, using only coconut fiber results in a mattress that is slightly firm. In high-end mattress factories, the production process often includes cotton padding. After being loosened, the coconut fibers are sent to a mixing machine where they are blended with cotton. This combination optimizes the benefits of both materials. Coconut fiber is firm, elastic, and breathable, providing excellent support, but on its own, it can feel too rigid. Cotton, on the other hand, adds softness, enhances breathability, and reduces the overall weight of the mattress compared to using coconut fiber alone. The ratio of coconut fiber to cotton varies depending on the specific product. Once mixed, the coconut fiber and cotton are layered until the desired mattress thickness is achieved. The layers are then hot pressed to shape and bond them before being cut into different mattress sizes. Coconut fiber naturally contains lignin, a substance that becomes adhesive under high temperatures. During the hot pressing process, lignin melts and binds the fibers together without the need for synthetic glue. This means that a higher coconut fiber content leads to stronger natural adhesion. Additionally, some manufacturers use natural latex to enhance the bonding while keeping the product eco-friendly and safe for users. Finally, the mattress is wrapped in specialized fabric to improve durability, comfort, and aesthetics. This is a perfect, nature-inspired product designed to enhance human well-being. It contains no microplastics or metal components, decomposes naturally, and does not harm the environment. Indeed, human creativity knows no bounds. As long as we have a deep love for Mother Earth, I believe that many more eco-friendly products like this will be created in the future. Thank you for watching the video. Let us know your thoughts in the comments below. Don't forget to hit the like button and subscribe to support the channel. For now, goodbye and see you in the next video. There is a type of plastic used to make foam boxes that we encounter daily in our lives. It is marked as number 6 in the resin identification code system, meaning this plastic is difficult to decompose, hard to recycle, and emits extremely toxic gases when burned. There are no official statistics on the amount of this waste. However, given its dense presence in our daily lives, we can confirm that the amount of this plastic waste released into the environment is enormous. And yet, most of us often throw it away without a second thought, assuming it cannot be recycled. If you're living in a poor or developing country, that might be true, because it's very hard to find facilities that buy or recycle it. But what if you're living in countries like Japan, the United States, or in Europe? Don't be so quick to discard it, because it can become a valuable material used to produce building materials, to construct highly efficient houses, And especially, it doesn't need to be burned. So how does this special recycling process, which does not involve burning, actually work? Let's explore the process of producing EPS lightweight concrete bricks in today's video. Every recycling journey starts with collection. Foam boxes are collected from various waste sources. We can find them at stores, supermarkets, or simply from households. Usually, when collecting used foam boxes, buyers choose ones that aren't too dirty. This also encourages users to rinse them briefly before handing them over, since it doesn't take much time or effort. These foam boxes are then transported to the factory, where they are sorted to ensure all unrelated waste is removed. The interesting thing about recycling EPS foam into lightweight concrete bricks is that as long as the foam isn't too dirty, there's no need to wash it thoroughly like with other plastics. And the final product's quality isn't much affected. This flexibility makes the EPS foam recycling process faster and more efficient. After sorting, the EPS foam is fed into a foam shredder. This is one of the most important steps, as it transforms the foam from raw form into small pieces that are easier to handle. The shredder works by using sharp blades or strong rotating shafts to break large foam sheets into small fragments. This process not only reduces the foam's volume, but also makes it easier to mix with other components during brick production. These foam pieces will serve as the perfect condition to mix with cement and sand to form lightweight concrete. Once the EPS foam has been shredded, the next step is to put it into an industrial mixer. This mixer has powerful paddles that evenly blend the components: foam pieces, cement, sand, and other additives. These additives may include binders, water reducers, or flame retardants, depending on the specific requirements of the construction. The purpose of this step is to create a uniform mixture with precise proportions of EPS foam, cement, and sand to ensure the strength and durability of the bricks after production. Thanks to the lightweight nature of EPS foam, this mixture will be very light but still offers excellent sound and thermal insulation, far superior to conventional bricks. This is why EPS foam bricks are increasingly favored in construction projects. After the mixture is evenly blended, it is transferred to an automatic molding machine. This machine contains pre-designed molds that shape the bricks. These molds are made of durable metal that can withstand the temperature and pressure of the lightweight concrete mix. The molding process not only ensures the bricks have a standard shape, but also guarantees uniform size for each brick, making construction easier and faster. At this stage, the lightweight nature of EPS bricks becomes evident. When the mixture is poured into molds, high pressure is not required because EPS foam creates an air bubble structure that makes the bricks significantly lighter than conventional ones. This air bubble structure is key to providing excellent thermal and acoustic insulation for the final product. After molding, the bricks are transferred to a drying chamber, a closed space with carefully controlled temperature and humidity. This process is essential to help the bricks solidify while maintaining their ultra-lightweight properties. Depending on the scale and technology, the drying time may range from several hours to a full day. Inside the drying chamber, the bricks are exposed to suitable temperatures that help the cement and additives bind tightly, forming a solid structure without burning the foam particles in the mix. However, this temperature does not reduce the brick's lightness. Thanks to the air within the EPS foam, the bricks retain their ultralight weight, making them easy to transport and install on construction sites. After drying, the bricks are hardened and go through a final quality check. This inspection process is strict to ensure construction material quality. The bricks are tested with fire and checked for hardness and strength. Once it is certain that the batch of concrete bricks meets the standards, they are packaged and ready to be delivered to construction sites. If you're not a construction engineer or builder, you might wonder whether these bricks compromise the sturdiness of a building. But let us reassure you, the strength of a house depends on many factors, such as the ground foundation, the house footing, key construction materials like concrete and steel, the skeleton of the house. Bricks play a supporting role in transmitting force, but are not the deciding factor. Their main function is to enclose, divide space, and provide sound and thermal insulation, contributing to the protection of the structure. So, from seemingly useless foam boxes, through a simple and efficient process, we have created ultra-lightweight bricks. Produced from recycled EPS foam, these bricks not only offer excellent sound and thermal insulation, but also stand as a testament to creativity in recycling and environmental protection. EPS lightweight concrete bricks are a smart choice for building sustainable and cost-effective homes. This shows that humanity is becoming more responsible for what we produce. We are maximizing the use of the Earth's gifted resources and avoiding waste. And as we've said many times, the most sustainable solution is to use eco-friendly alternatives, not to mass-produce harmful materials and figure out how to recycle them later. Every small action carries great meaning. Thank you for watching this video. See you in the next one. If you've ever seen a pile of old tires covered in dust under the scorching sun, you might think, this is just trash. But with a shovel, a sledgehammer, and a bit of sweat, that pile of trash can be turned into a dream house. Cool in summer, warm in winter, and no need for air conditioning. Sounds unbelievable? Then you'll be amazed at how people build houses using old tires without crushing them or using any chemicals. Let's explore with IronHand tech. Earthship is the name of a unique housing model born in the 1970s in the United States by architect Michael Reynolds. These are not your typical houses. They're designed to make maximum use of waste materials, like plastic bottles, aluminum cans, and most notably, used car tires. In an Earthship, the walls are not made of bricks or concrete, but of thousands of used tires, packed tightly with earth. Once filled, these tires become super durable building blocks with excellent insulation, thermal mass, earthquake resistance, and soundproofing. The amazing part is, to build a wall like this, there's no burning, no crushing, and no chemical treatment involved. Just soil, tires, sweat, and persistence. To build a house from tires, of course you need tires, which can be collected from garages or scrap tire yards. Worn-out tires that are no longer roadworthy are still perfectly suitable for construction. The more uniform the tires are in size, the easier and more aesthetically pleasing the structure will be. And the older the tire, the more cost-saving it is. As long as it isn't torn, it's good to go. And just like that, something once discarded becomes building material the moment it's loaded onto a truck. It's ready for a new journey with a new name, Earthship Building Material. The ground for the house has been prepared. When clearing the land for the foundation, the soil is not discarded. It's collected to become part of the building material for the house itself. Amazing, isn't it? No need to buy cement or sand. You don't need an engineer, a cement mixer, or complicated machinery. Instead, all you need is a shovel to scoop soil, a sledgehammer to pound soil into the tires, a small wooden board, cardboard, or old sack to line the bottom, and a pair of thick gloves to protect your hands from getting tired. For the first rows of tires placed on the ground, no liner is needed. Builders place the tire directly on the ground and fill it with soil. Then, using the sledgehammer, they pound around the tire in a circular motion to compact the earth inside. To keep the rows straight, the builder uses a stretched line and stakes at both ends for manual alignment. If the wall design follows a curve or arc, the structure becomes even more stable due to evenly distributed force. That's why many earthships use semicircular or elliptical wall designs. From the second row upwards, liners are used. Empty tires are placed atop the fully packed ones below in a staggered formation to increase stability, prevent vibration, avoid cracks, and improve aesthetics. Liners are inserted to prevent soil from falling through during the initial filling. After pounding, the soil will hold firmly inside the tire. No cement, no glue, no frame needed. Just even, tight, and strong tamping. Each tire takes 10 to 15 minutes to pack, but will last for decades. A filled tire weighs about 100 to 150 kilograms. Too heavy to move, and thankfully, it doesn't need to be moved. That's why the correct process is, place the tire first, then pack it in place. Don't try to lift a tire brick once it's filled. You'll regret it. And so the process repeats until the wall reaches the desired height. It can go up to 3 meters and still be safe. And incredibly, tire walls like these even provide a certain level of earthquake resistance. Once the wall is built high enough, there will be triangle-shaped gaps between the tires that need to be filled. Leaving them open makes the wall unstable, as weight from above doesn't distribute evenly, potentially leading to collapse during vibrations. These gaps can be filled with clay or the same soil used for the tires, but it mustn't be too loose. Small stones can also be added to increase bonding and evenly distribute force. For a more aesthetic and smooth wall surface, homeowners can stuff small stones inside and use a mix of earth plus sand plus cement or earth plus lime plus straw to fill and plaster the exterior. After plastering, a final coating is typically added. This helps waterproof the wall, protect it from rain, and improve appearance. Some people leave the tire contours visible, giving the wall a raw, rugged, and unique look. Others smooth the wall, paint it, or decorate with mosaic tiles or broken glass, turning tire walls into works of art. The beauty is, you can customize it endlessly, as long as the outer layer is sealed and adheres well. This is not just the final step in building a tire wall, it's also the first step in shaping the emotional soul of the house. A wall that breathes with the earth, with renewal, and with our own spirit. For openings like windows and doors, simply install wooden or steel frames before continuing the wall. It's not much different from traditional building, except the material is thicker, stronger, and much more insulating. That's right, because your wall is over 1/2 meter thick. And of course, every house needs a roof. On the roof, heat-resistant metal sheets are installed at a slope to collect rainwater. A tank at the back filters the water using gravel, sand, activated carbon. Homeowners can also install a 1 to 2 kilowatt solar power system, enough to power lights, fans, and water pumps. Inside, skylights and cross-ventilation systems keep air circulating. Without air conditioning, the house still stays cool, something even modern concrete homes can't always achieve. This is what makes tire homes more than just shelter. They become a space to live in harmony with nature. It might seem like building tire walls is so easy that construction engineers could lose their jobs. Just kidding. But truly, this building method is so accessible that anyone can do it. That's why tire house models have become attractive in areas with limited construction resources, remote regions, and even in DIY community projects. Everyone can join in. Building a tire house offers many clear benefits. Financially, the cost is incredibly low, with almost free main materials. Technically, no need for complex machinery. Environmentally, you're reusing one of the planet's hardest to decompose materials. In terms of living experience, thick walls, cool air, no need for air conditioning. It's not just a housing solution. It's a green, self-reliant, creative, and deeply human lifestyle statement. If you think this model is worth trying, don't hesitate to share this video. IronHand Tech will return soon with more eco-friendly and planet-saving videos. If there's a recycled material you'd like us to feature, leave a comment below. Thank you for watching and see you next time.